Okay, so we are starting chapter 10 today, which is properties of circles. Section 10.1, we're going to stretch this out over a number of days, and the first day is really an introduction to a whole lot of vocabulary. So I'm going to share some notes I have that already have most things written in them and add some details for you as we look through. And then I will post the completed set of notes up for you as well. Section 10.1 is called Use Properties of Tangents. But like I said, today is mostly just looking at some vocabulary and all the different terms that we're going to use. This warm-up exercise is really just to remind you that when you square a sum, make sure that you get that middle term. If you need to, write it out as x plus 18 times x plus 18. But the rest of this you can look at in the completed notes. So there's a lot of definitions in this section, and I have most of them written out here for you. We're going to use the diagram at right to look at them. By definition, a circle is a set of all points in a plane that are equidistant from a given point. It's a two-dimensional figure, and this is why a compass works. It draws the circle at all the points that are that same distance from where you put the point of the compass on the paper. So when you have a circle, we can use a circle symbol, and the circle symbol is a circle with a dot in the middle. And you name the circle by the name of its center. The center is the point that each point is all the other points are equidistant from. So this is circle O. Please excuse my writing for today. I'm hoping to have some better tools to use in the next week or so. So O is the given point. This is circle O. The radius of the circle it has two meanings really. It's the segment, any segment whose endpoints are the center and any other point on the circle. So we could draw a radius, for example, from O to B, or O to D, or O to E, or O to C, O to any point on the circle. And it is a segment. So when we write a radius, we would write the name and put the segment symbol over it. This is going to be important whether we're using segments or rays or lines for some of these terms. Radius also refers to the length of that segment. The radius is as far as how long is the radius. Another term, a chord. A chord is a segment whose endpoints are on the circle. It goes from one point on the circle to another. So if we look at this diagram, I have a chord from A to B, one from C to D, and another one from E to F. These happen to all be drawn parallel, but I would name them again as segments. I have segment AB, I have segment CD, and I have segment EF that are all chords of circle O. A diameter is a chord that contains the center of the circle. So in this circle, the chord CD is also a diameter. And again, like radius, the diameter refers to the segment as well as the length of that segment. A couple other terms. A secant. A secant is a line that intersects a circle in 2 points. So segment AB is a chord starting at A and going to B. Line AB, remember the line symbol with arrows at both ends, is a secant. Another way to define a secant is a line that contains a chord. It goes through the chord and continues in both directions. A secant intersects the circle in 2 points. A tangent is a line in the plane of the circle, so it cannot be coming out of the plane, that intersects the circle in exactly 1 point. So if we look at this line here, CE or CD, however I name it, it intersects the circle at only point D. That line is a tangent line. We call it CE. Every tangent has a point of tangency. The point of tangency is the point where the tangent intersects the circle. In this diagram, line CE is tangent to circle O at point D. We can also talk about tangent segments or tangent rays. That would be a part of this line that included the point D. So if we look at this diagram, we can find, we're going to give the best term for each figure. And so if we look at F, we see this radius coming out and hitting F, and F is where this line touches the circle H. So in this diagram, F is a point of tangency. Excuse my writing. Line FE is a tangent line, and line FE is actually tangent to two different circles. Line FE is both tangent to H and to circle C. Segment HG goes from the center H out to the edge of the circle, so that is a radius. Segment DB, D is a point on the circle, B is a point on the circle, and the segment connects them, so that is a chord. Point C, don't think that these diagrams are trying to trick you in any way. If it looks like the center of the circle, it's the center. Segment BE, again, B is on the circle and E is on the circle, so it's a chord. And because it goes through point C, it's not just any chord, it is a diameter. I forgot to erase some of the stuff down here. There we go. Line DB goes through D and B and intersects the circle at both of those points. So that is a secant line. Notice the difference between number 4 and number 7. If it's a segment, if it's a chord. If it's a line, it's a secant. And then line AG. AG is tangent to circle C and tangent to circle H. We're going to talk about the lines that are tangent to two circles a little bit more, but this is also a tangent. Couple other terms, lots of vocabulary again today. Coplanar circles. We know that coplanar means they're all in the same plane. When we have coplanars, they can intersect in 0 points, 1 point, or 2 points. Tangent circles, so circles that are tangent to each other, are coplanar circles that intersect in 1 point. And you can see there's two different ways that those circles can be tangent to each other. In the first picture, they are external to each other. In the second picture, one is internal to the other. But in both cases, they're only touching at a single point. And concentric circles, this is your bullseye. These are coplanar circles that have a common center. They will intersect in 0 points because they do not cross over each other at all, but they have the same center and a different radius. Again, think of a bullseye. Couple more. Common tangents. This is a line, ray, or segment that is tangent to two coplanar circles. And there's two different ways this can happen. In the first picture on the left, we have internally common tangents. What do we mean by internal? Is that if we connected their centers, the tangent would cross over that line between the segment joining those two centers, as opposed to the diagram on the right, where if I connect these centers, the tangent does not cross it. So we have internally common tangents and we have externally common tangents. And depending on how the circles are positioned relative to each other will determine how many of each you could have. This was supposed to be an exploration, but it's already done for us. If we have a circle O with a radius OA drawn somewhere, and then we draw segment AT perpendicular to OA, when we look at the diagram, we can see that AT is also a tangent to that circle. There's a theorem that says in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint. So if TA is perpendicular to the radius OA at point A, then it must be a tangent. Or if we knew that TA was a tangent, we would know that it would have to be perpendicular to the radius drawn to the point of tangency. That's the if and only if. It works in both directions. And one more theorem. If you have a circle and you draw two tangent segments to the circle from the same point on the outside, it's kind of like an ice cream cone. If we look at this, it appears, and it is true, that those two segments will have the same length. So we had a circle with point P outside of the circle, and we do a tangent from P to A and a tangent from P to B. They will always have the same length. Tangent segments from a common external point are always congruent. I have some more examples in here that I'm just going to post for you. Most of tonight's homework is naming and then looking at whether or not segments have to be tangent. So if AB is a tangent, it has to be perpendicular to BC. So you could use Pythagorean theorem to check if it is a tangent, or in this example, 8 squared plus 16 squared is not equal to 19 squared, so that is not a tangent. I would definitely look at example number 11. What we have here is we're trying to find the radius, and we know the length of this tangent segment and this external part of this segment. And so we have to do Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. Make sure you can square the binomial x plus 32 to get that middle term. Remember, it's a squared plus 2ab plus b squared. So here, x squared plus 2 times 32 times x plus 32 squared. And then you would go down and solve for x. And we can do examples where we're given those two tangents drawn from the point outside the circle, and all we need to do is set them equal to each other. I think that is it for today. And you have an assignment. I'm going to ask you to submit a picture of that assignment by Sunday evening. Friday is a work day. We're not going to give you much homework on any given night. Today you have the Friday also to work on it, so giving you a little bit more. We're trying to spread this out, and please let me know if you have any questions.